Okay, now comes the summarizing of the data set. Summarizing in the sense we need to check the data set, how it is, whether the raw data is there or it is a clean form. So we need to do some change if it is a raw data, or if you want to change it means you can change that thing also in this summarizing part. So for that reason I am using the shape statement. For this data frame we need to provide here what the name you are given in the loading of the data set. So if we pass this statement, if we run this code, we are going to see the number of rows and the number of columns in our code. So there are 150 number of rows are there in our data set, and there are 5 number of columns. With respect to output, it is going to show the columns. Okay, there are 4 input outputs and one is the output. So it is displayed the number of rows and the number of columns. For that reason, we are using the same shape. So here the head statement. If you pass the head statement, let us remove this 10 and check. We'll check what will happen. Okay. Now see, we are going to see the first 5 rows of the data set. So if you pass 10 over here, you are going to see the 10 number of values. So you can analyze how the data is by the head statement. Okay. And next will be the tail. So as we have seen the head statement here, as that the tail statement is going to work exact opposite of that. Here we are going to see the last 10 data sets from 140 to 149. So like this we are going to analyze how the data set is looks like. Okay, these are the 3 statements. It is very important. And next is the most important thing, that is a describe of the data set. That is in the describe what we are going to see. We are going to see the statistic summary of the data set. That means it is going to tell us the number of each column values, how many are there in the single column and how many are there in the second column, third column. Like this it is going to display all the values. Let us run the code and we'll see. Okay, here you can see for the simple length we are having the count of 150, and simple width we are having a count of 150, and petal length we are having 150, and as well for the petal width having the 150 values. Okay, you can see here no missing of the data. So we can predict that the data set is now ready for the prediction. So if all the values are equal means, so no missing data is there in the data set that we can analyze by the describe statement. So it is also displaying the mean value of the column and the standard deviation and the minimum value, 25% value, 50% value, 75% value, and the maximum value. These are the things what are there in single column. So this refers to the simple length column, and these values are referred to the simple width column, and this is referred to the petal length, and this is referred to the petal width. Okay, this is all about the statistical summary of the data set. Now we will see what this statement is going to do. So we are using this data types because if we want to know the type of data in the data set, whether it is a character or object or a number, integer type or a float type. So if you pass this and you will run, we are going to see the type of the data set. So you can see the simple length, simple width, petal length and the petal width all are of the float values. You can see here. So all are float, right? So it is going to display as a float, and class is nothing but the character, so it is displayed as the object. So the data set is consisting of the float values and the object. Okay, I think you are cleared with the summarizing of the data set. Okay, I will move further in the data visualization. So visualization in the sense it is nothing but analyzing the data set with respect to the graphs. So there are many kinds of graphs are there. So I am using here the box and the whisker plots and the histograms and the scatter plot matrix. These are enough for the visualization thing. Okay, just I am using the data frame values and this plot statement, and the kind of graph I am using here the box that I mentioned here, and In the subplots true means it is going to plot the graphs separately. If I make the subplot false means it is going to plot the graph in a single axis. For that reason I am using the subplots true statement. Next is the layout. Layout is nothing but the how many number of graphs you need in a line. So 2 cross 2 means in a single row you are going to draw the two graphs, and another is the another row you can go, you can get another two. That is, you are able to get the 4 graphs from this. You can use any of your, if it is your wish. So for the simplicity I am using it as a 2 cross 2. Then next is the share x false and the share y false. It's nothing but the sharing of the x axis and the sharing of the y axis. If I make these true means the all the things are going to plot in the single graph. That is, it is going to share the x axis as well as the y axis. So if we do that thing means we are not going to analyze it properly. So I am doing it as the separately. Let us run the code and we'll see what we'll get. Okay, you can see the plots of the data sets. It is the zipper length, zipper width, pitter length, and the pitter width. Okay, here in the box plot what we are analyzing is, it is going to tell us the minimum and the maximum values in the data set. So here you can see from 5 point something values to 6 point something. In that range the zipper length values are there. Similarly, with respect to sepal width, this is the from 2.8, I think, from 2.8 to 3.8. So these are the values where sepal width column values are lying. And similarly, with respect to petal length, the minimum value is this thing and maximum value is this. Here in the petal width, minimum value is this thing and maximum value is the around 1.8. So we can analyze these things by the box plot. Okay, we'll move to the next graph, that is the S and S plot. This is nothing but the same. You can whatever we have done with respect to box, but the another graph, but it will be in 3D form. Okay, here the axis is shared, so you can analyze with respect to the minimum and maximum values in the separate column. So in sepal length this is this thing, and petal sepal width this thing, petal length and the petal width. So same as this thing. For your understanding purpose I have used this thing. If anyone you can use, that is more than enough. Okay. Next comes is the histograms. Let us run, we'll check. So histograms are nothing but the graphs where we are going to see the in the x-axis where the values are located, that we are going to see in the x-axis, whereas in the y-axis we are going to count the number of occurrences in the data set. See here around up to 30 to 40, up to, we are not displayed here, 30 around up to 38 our values are there. Here from 2 to from 2 point something is there, that we can't able to see that correctly, but we need to analyze. So up to this thing the value has been repeated. So here in this from 1 to here this many times the value is repeated. So the y-axis is going to count the number of occurrences in the data set. Same way with respect to all the 4 columns, it is going to display the graphs here where the occurrence has been occurred and the how many times the value has been occurred. Okay, this is about the histograms. Just we are going to the scatter plot matrix. Scatter plot matrix, just I will run this code and I will explain you what scatter plot matrix means. So here in the scatter plot matrix, scatter plot matrix are used for spot checking the input variables. That is, here in the diagonals you can see the histogram plots. Here this is the sepal length. Here you can also sepal length. So this is the histogram of sepal length. This is the sepal width and the sepal width. This is the petal length, petal length. This is petal width, petal width. So this is the histogram of the data set. Here you can see the pointed dots. So this is going to tell the relationship between the here in the first graph, the first row, you are going to see the relationship between simple length and the petal width, where the occurrences of values are there. Similarly, with respect to petal length and the sepal length, you are going to see here. With respect to sepal length and the sepal width, you are going to see the occurrences of the input values. So, by this you can see the relationship between the two input variables. So, this is all about the visualizing of the data set. So, till now I have explained you the visualization and the importing of the libraries and the loading of the dataset. So the half of the work is done. Next comes is the evaluation of the algorithms. For that reason, we are using the training and splitting. So what we need to do is first we need to train our dataset, and after that from the training we need to test. For that reason only we are splitting the datasets. Basically, uh, the generally we are going to split the dataset in 75 to 25. Either either if you don't want to have 75 and 25 means you can do it for the 80% and the 20%. That is 80% you can use it for the training purpose and 20% you can use for the testing purpose. Same way we are using this. Here I am using the validation size as the 20%. That is nothing but the testing size. So I will explain the code one by one. Here for the array we are giving the values of the data frame. So the array is now going to fill the values of the data frame. After that for the x we are splitting it into input attributes and the output attributes. So for x we can give it as the input attributes, and for the y we can give for the output attributes. So this is nothing but the slicing of the data set. So this uh, 4 means we are having the 4 input out attributes. So for that reason we are loading the input attributes as x. So we are using this technique. So this is nothing but a slicing, and this is the y. So in the y we are giving only with respect to the output. Okay, this is nothing much confusion in that. Just I will print the x and you are going to see. First I will run this thing. Let us comment this thing, otherwise you will get confused. Okay, I will print only with respect to the x. Okay, now I will print x. I will see what the output will get. So here you can see that all the input attributes are displayed. Okay, that means by this. So I will also print y. You can see what we are going to get. Okay, these are nothing but the class that we are loading into the, for the x and the y. I will just remove this. Okay, so now I am using validation size or the testing size at 20%. So seed 7 is nothing but the random state value. That is, random state means it is going to generate the attributes again and again. For the training and testing purpose, it is very much essential. So it will generate the input values again and again, how much we are giving it for the seed. If you give 7 means 7 times, if you give 8 means 8 times. So this depends on the value what we give feed to the seed. Okay. Next comes the training and splitting of the data set. So here the x train we are giving the x values what we are giving, and the x validation, that is x testing, y train and y testing or y validation, anything you can give, no problem with that. So here you can see the train and test split. So this thing we have inputted in the above library, what I have explained it in the first video. So here x and y, that is input and the output, we are going to give these two values, and here we need to mention the validation size or the testing size what we are given in the here, that we need to give here. And next is the random seed, that is 7, that we need to specify here. So it is going to train and test the splitting data. So after running this code, you are going to understand what this statement has done. Okay. So first thing is the extend shape, that is it is going to tell the number of rows, number of columns. That means it has split it as 120 number of rows and 4 number of columns. And X testing, it is split at 30 rows and the 4 values, 4 columns. So the Y training validation is nothing but the 120 values, and the Y testing is nothing but the this thing 30. Okay, it is split as a 30. Okay, you can see how the splitting of the data set has been occurred with respect to 80% and 20%. We are having around 150 number of rows, right? So in that 120 is the 80%, and another remaining will be the testing purpose. That is 30, nothing but the testing data. So this is about uh, training and testing or splitting out of the data set. So after that, next comes the spot checking of the algorithm. Spot checking algorithm means we need to predict which algorithm going to work best for our data set. For that reason, we are going to import all these algorithms, and we are going to analyze which will give the more accuracy. So for that reason, we are importing the models over here, and we are appending the logistic regression for these models and the linear discriminant analysis, k-neighbor, decision tree, Gaussian NP, and the SVC. These are libraries we are appending for the model. So next comes the evaluation of the model. So we are using the for loop. So here for the name model, the models. So name is nothing but the algorithm name, that is name means. So model means which model we are using. That will come here with respect to these things. Okay. For that, for in this for loop values, it is going to do the k-fold times. That is, in split 10 means it is going to split the data set 10 times, and the random seed value always already were given here as a 7. So same value is taken here. So it is going to fold the data set 10 times. In the 10 times, it is going to split again for the 10 times in again in 10 times in 1 times in 1/10 it is going to split again 10 times. The ninth prediction, it is going to give output as the output in the 10th format. Okay. Next comes the CV result. That is CV result. In the cross validation score, we are imported this thing in the libraries. So it is going to do what I explained now. It is going to uh, you know for this k fold, it is going to take, if I have given here as a 10 means, it is going to split it as a 10 times, and again from 1/10 it is going to take one part, and in one part it is going to split again 10 times, again 10 times, and then 9 times it is going to split, and then the 10th it is going to give the value. That is the accuracy what we are going to predict. So this is nothing but scoring the accuracy over here. So we are seeing the how much accurate is our model. So for that reason, we are using the accuracy. If it is a regression type of problem, means we are going to use here the regression. Negative means speed error. Okay. So we are going to append the results, these things, uh, CV results to this result that we have left empty. And for the names, these things, we are going to append the name that is nothing but the algorithm name. So here we are using the percentages, means that is the name which algorithm, these are called as the name that are going to display in the output. And then next is the percentage of that is for the float values, how much accurate the algorithm that is going to display. So we'll run the code and we'll see what happens. You can see here the best suited model is a KNN, sorry, SVM. It is got around 99% of the accuracy. So for our this Irish flower data set, this SVM model is the best suited. So from that we are going to predict the classification matrix as well as the confusion matrix as well as the accuracy. So after doing these things, we'll move into the prediction part. So here you can see we are importing that algorithm, and for this algorithm we are going to fit the X train and the Y train values. The predictions we are going to feed with the predicted value of the X testing, that we are moving into the prediction values. So, and with accuracy, what we need to get the accuracy is the Y validation as well as the predictions. The Y validation is nothing but the Y testing values, and the prediction is nothing but the what the SVM algorithm has been predicted. You can see if you want, I will show you the predictions. You can see these are nothing but the predicted values, and we also check what is the validate testing uh, result. This in these two only it is going to uh, verify which to get the accuracy score and the confusion matrix. Okay, as well as I have not commented these things, so that result also printed here. You can see I will just comment these two lines so that you will get confused. Okay, now we can see we got around 93% of accuracy, and this is the confusion matrix and this is the classification table. So I have explained in my previous video what the classification table is and what the confusion matrix is. So I think you have no doubts regarding the confusion matrix and the classification table. Here it is predicted the 7 correct values, and 00 means accurate modalities, and here it is the 10 number of values, and 2 it has predicted wrongly, and the third one is the 11 values. Here also no error. So this is all about the confusion matrix. Next comes the classification table. Here for the iris setosa there are 7 number of values are there. So precision is nothing but the it is the ratio of true positive values divided by true positive values plus false positive values. Samely, the recall is nothing but the ratio of true positive values to the true positive values plus false negative values. And F1 score is nothing but the average of that is the precision and the recall, that is P into R divided by P plus R. That P stands for the precision and R for the recall. That whole thing we need to multiply with the 2. From that we are going to get the F1 square, and the support is going to the total number of values, that is 30. Totally there are 30 number of attributes are there. Here we got 30 only. You might confuse why the data set consists of the 150, so we got 30. So but we are going to analyze with respect to the testing part, testing data set, only testing part. So we are getting only 30 number of values. So you can also see the average total of the all precision. From this it is going to predict the accuracy, that is 93%. So we can see here confusion matrix, that is true positive, false negative, false positive, and true negative. Okay, the accuracy, sensitivity, everything is there in my video, so you can check it out if you have any confusion with respect to the confusion matrix. I will move further. So this is the last step of the problem, that is the finalizing of the model. So we are finalizing our model for the next purpose or the further use. So for that reason we are doing once again with the splitting of the data set with respect to uh, in training and the testing. That is, we are using the 33% for the testing size, and we are another rest 60% we are using it for the training purpose. So we are splitting it with respect to the 66 and 33. Next is the fit model. So this SVC is the best suited model, so we are using that thing. And for model fit, we are going to fit the X train and the Y train values. So to save the dataset, this is the syntax dump. We are importing it for the pickle that I explained in the importing of the libraries. So this WD means it's writing into the dataset. Sorry, writing into the disk. So after that, sometimes you need to load it. After that, we can read the dataset and the accuracy also, everything whatever the we have predicted here. So for time being, I'm displaying with the respect to only the accuracy over here. We'll just run the code and we'll check what happens. So here the little bit of accuracy has been increased. It is why increased means here we have changed the testing size. Here we have changed the 33%, but here we have a testing size of around 20%. So the model has been changed. So for finalizing model, we need to change that ratio, so we can get the more accuracy. So the model is around 96% of accuracy. So I think I will just summarize the things whatever I did till now. So the first is the analyzing of the problem. So in the analyzation, you have come across the classification with respect to the these four attributes and the one final output attribute. And next is the loading of the libraries, and next of the loading of the data set and the summarizing, and next is of the data visualization. Then we have splitted the data in terms of 80 to 20, and next we have spot checked the algorithms and we got SVC as the best suited algorithm for our data set. And next, with respect to SVC only, we have predicted the accuracy classification table as well as the confusion matrix. So this is the good score. So in the next video, I am going to show you the banknote dataset. That is also a classification type of problem. Until then, if you have any doubt with respect to this Irish flower, please do comment in the comment box. I will try to answer it. Okay, thank you for watching. Please do subscribe for my videos.